Hello everyone, how are you all? How is the preparation going? So, this is the day 2, that is class 2. Beforehand, let me tell you that I am not a teacher. I myself am preparing for various competitive exams. So, I thought why not to share my notes with you all and have an have a discussion sort of thing. Like if I'm able to help you all, that I would be very happy about it. And if you feel that I'm missing some points, please do let me know on the section, because that would be helpful for me as well. So this is like a mutual benefit for us. Yeah. So I know, like, let me tell a short backstory that while I was in college, back in my hostel days, when I used to come back from college, we friends we used to sit together and have a group study. Okay, so we were from different colleges. So in certain colleges, one, two or colleges, there were no professors available for the particular subjects. So what we used to do was we used to sit together and we used to explain each other. We used to teach each other, like we used to play teacher and sort of that. So we used to explain each other, and thereby we used to understand the concepts. They used to ask questions, and thereby we can get the new perspective of that topic. So I thought this way I could also learn more about it. So that's it. So that's why I started this channels. I can also gain from that. Like if I'm explaining you guys, I try to learn more about it. I try to procrastinate less and learn more about it. So it's about it. Yeah. So that's it. So that's why that's why I wanted to tell you that I'm not a teacher. So you can expect a student level of knowledge from myself as well. It would be helpful, and I would be thankful for you all if you will help me in written. Yeah, so let's start where we stopped yesterday. Okay, so yesterday we said that in order to find this Q, we have to find the population at the end of design period into per capita water demand. Now this per capita water demand, it remains constant throughout the years. So the main thing is we need to find the population at the end of design period. So in order to find that, we have few methods. Okay, now this population growth, okay, this follows a logistic curve or population growth curve. Okay, so under normal circumstances, this population growth of any community usually follows this logistic curve or population growth curve. And these methods, there are certain methods that I'll be telling you about. So those methods, these are based on law of probability, because we know that we can only predict the future. We can't be certain about this thing will happen definitely. Okay, so we can only predict about the future, and we won't be 100% sure about it. So that's basically the law of probability, like 50-50 chances, or 60-70 chances, 80 chances, 90 chances, but not 100% chances. Okay, so it's all about probability. So as I said, there is no 100% guarantee that this would be the population after n number of years. It's all about law of probability. Now this population growth, why it's not 100% sure? Why? Because this population growth, there are certain factors which is dependent upon this population growth, like birth, death, migrations, and natural calamities or wars. These are unpredictable. We can't predict it 100%. So that's why it said that there is not 100% guarantee about the population growth after n years, but still we can work it on the basis of law of probability. And the methods to estimate this population forecasting are arithmetical increase, geometrical or uniform increase, incremental increase, decreasing rate method, simple graphical method, comparative graphical method, and logistic curve method. Okay, so first we'll be dealing with arithmetical increase. Okay, let's start with first the arithmetic increase method. So this method now, it's best suitable for old, well settled and large cities, like where the cities have already been established and there is no more chances of increase in the population, like drastic increase in the population, which is already well settled, it's old and large and has reached the saturation or maximum development. In that case, we'll be using this arithmetic increase method. And the rate of change of population with time is assumed to be constant because there is no rate of change of population happening in this case. Okay, so the case where the rate of change of population with respect to time is constant and the cities which are old, large, settled and which has reached the saturation point or maximum development, therein we'll be using this arithmetic increase method. The formula for arithmetic increase method is Pn is equal to Po plus nx bar. Now this Pn is what? Pn is the population that we need to find after n number of years. This is the n number of decades. Okay, so this n is represented in the form of decades. So P, the population after n number of decades, that we need to find. That's the main motto of these methods. Okay, so P0, PO or P0, whatever we pronounce, what is that? That is the present population. Right now when we are sitting and estimating the population, at that point, what is the population? So that is the present population that we'll be taking here, plus n. N is what? Number of decades. Like 10 years now we'll be taking, like 1981, then 1991, okay, 2001, so thereby 10 years. So this is the number of decades. And this x bar, what is x bar? X bar is the average population increase per decade. How will be calculating? We can know more about it, how to calculate this x bar through numericals. It will be clear more while doing the numericals. Okay, so once again, arithmetic increase method, this is suitable for old, large, well settled and the cities which have reached a saturation or maximum development. The rate of change of population with respect to time is assumed to be constant. There is no drastic change, drastic increase as well as decrease in the population. Like the population remains constant throughout. Not much change, like little slightly here and there, but not much change. Okay, so in that case we'll be using this formula, that is Pn is equal to P0 plus nx bar. Okay, so the first numerical is assuming arithmetical increase method, population of the town in the year 1991 with the help of following census records of the population will be. So we need to find the population for the year 1991. The data given to us is year 1951, 1961, 1971. Okay, 10 years ka difference. The population in thousands, that is 255, 495 and 735 respectively. Okay, so now we need to find the population for the year 1991. So could you please pause this video and try to solve by yourself? So I hope you have paused the video and try to solve by yourself, and I'm sure you must have gotten this answer. If not, we'll see how we will get this answer. Okay, so year has been given to us, that is 1951, 1961, 1971. Population has been given to us is 255, 495, 735 per decade increase in population. Now this is new to us. These two are the given data. This is what we are finding. Okay, what is this? This is nothing but this x bar. This will lead to x bar. We have the formula na Pn is equal to Po plus nx bar. So how we'll find this x bar? From here. How? See, per decade increase in population. It's increase in population, na? Arithmetic increase method. So it's increase in population. How much is it increasing? So difference between these two. 495 minus 255 will give 240. 735 minus 495 will give 240. Now let's take the average of this. Only 2 are given, so we'll be dividing it with 2. Okay, so if we'll take the average of it, we will get 240. So this x bar, from definition, what is this x bar? It's the average population increase per decade that we have studied earlier. Okay, so X bar is average increase in population per decade. So that is what we got is 240. Now, from formula we have to find this N also. So what is this N? The population of which year we need to find? 1991. What is the present, latest? Which one is the latest one? 1971. So, minus it. 1991 minus 1971. But this is given in years, no? N is what? It is the number of decades, right? So, we need to divide it with 10. One decade means 10 years. So, 1991 minus 1971 divided by 10, which will give us 2. Okay, if it was 1981, if we had to find the year, the population for the year 1981, N would have been 1. But this is 1991. 1991 minus 1971, 20 divided by 10, that is 2. Okay, finally, so we got PO. PO is what? 735, the latest population. N is what? 2. X bar is what? 240. We'll substitute these values in this formula. Pn is equal to PO plus NX bar, which is 735 plus 2 into 240, which will be getting 1215. But make sure, okay, in the data it was given population in thousands. So that means if it was 735, it was 735,000. So make sure if in the question it's asked to write the population in thousands, then we can write 1215. Otherwise, we need to mention the thousands as well. Okay, so I hope you got this. Let's move to the next question. Now the next question, this question was asked in GATE 2004. Okay, only one question has been asked from this chapter, and that too from the topic arithmetic increase method. Okay, so the question here is, the present population of a community is 28,000 with an average water consumption of 4,200 meter cube per day. The existing water treatment plant has a design capacity of 6,000 meter cube per day. It is expected that the population will increase to 44,000 during the next 20 years. The number of years from now when the plant will reach its design capacity, assuming an arithmetic rate of population growth, will be. So here we need to find the number of years, that is N. Okay, so could you please pause the video and try to solve by yourself? Okay. So I hope you got the answer 15 years. If not, it's okay. Don't worry. We'll solve it. Okay, so what is given to us? PO or P0, whatever we say, whatever you pronounce. The present population given to us is 28,000. The average water consumption right now, demand or Q is what? Discharge, flow rate. Current flow rate is what? 4,200 meter cube per day. Okay, now after 20 years, P20 means what? Population. After 20 years, it would be 44,000. This is also given to us. The design capacity of that water treatment plant is what? 6,000 meter cube per day. Okay, so these things are given to us. So now we have P0, we have N, that is 20. We don't have X. So first of all, we need to find X bar. Okay, the average increase in the population. Okay. So Pn is equal to P0 plus Nx bar. So Pn, here it is what? P20 is equal to P0 plus Nx bar. N is what? 20. P20 is what? 44,000. P0 is what? 28,000. N is what? 20. So from that we can find X bar. The X bar value we got is 800. Okay. Now, in the first class, we studied that Q, discharge or flow rate. That is what? That is population at the end of the design period into PCWD, per capita water demand. Okay. Now, per capita water demand, it is constant throughout. We'll be taking this constant. This PCW means what? Q by P. We can take PCW is equal to Q by P. Okay, now this PCW is constant throughout, so that means Q0 by P0 is constant, which will be equal to again Q0 by Pn. That means Q0 by P0 is equal to Qn by Pn. Okay, this is equal to this. This is also equal to this. That means this is equal to this. Basic maths. Okay, so Pn, from this equation Q0 by P0 is equal to Qn by Pn, we will be getting Pn value. Pn is what? P0 into Qn divided by Q0. Okay, P0 is what? 28,000. Qn is what? Given to us 6,000. Q0 is what? Again given to us 42,000. This is what? 40,000. Okay. The population growth, when the design will reach its capacity, maximum capacity, at that time the population is what? 40,000. But that time is what? What is that time? That time we need to find now. So Pn is equal to P0 plus Nx bar. Pn is what? We found out 40,000. P0 is already given to us. N we don't know. X bar we have already found out 800. So from this we can find the value of N is equal to 15 years. Right? We can find the value of N. There is a number of years. Okay. So the thing is, it's simple, but we should know where to introduce what. So here, till here we can get it. X bar is equal to 800. But then what next? We'll be most probably we can stuck here. Like X bar we got 800. But then what next? So then we need to go through the notes. Like we need to revise it. We need to remember the concepts and apply this concept here. Because in the definition I told that Q is equal to P into PCWD, that is per capita water demand. Here that concept applies. So the theory or the concept is very important to solve the numericals, right? So that's why you should not cram up the numericals. Like this is not how it will work. So if you want to be thorough with that, you need to be thorough with the concepts. Why theory is important? Because then only you will know what to apply where in numericals. Okay, so in this particular numerical, we applied this concept Q is equal to P into PCWD. And we know that, one more concept we know that PCWD, that is per capita water demand, remains constant. So from that we calculated this Pn. Okay, so we formulated this formula Q0 by P0 is Qn by Pn, and from that we got the value of Pn, right? So that is how we'll come to the answer. We can solve it. So please go through the notes, please keep on revising it. And why these notes? The theory is important because that only will help us to solve the numericals. Otherwise we'll get stuck somewhere here or some other points, especially when we are not thorough with the theory part. Okay, so that's it. These two are the numericals that we have solved today, and mostly these two numericals that I can find. There are many other numericals in the test series as well as in Google you can search about, but these are the main two types of. Like first one is indirect. You have to apply the concept and then you can solve, and the previous one that we have solved is directly applying the formula. Okay, so it's your luck what kind of question will come in the exam. If it is directly, you can solve it easily, but if it is like this, then you need to be thorough with the theory part as well. Okay, so thank you so much, and if I have left any point in this topic, then please do let me know in the comment section below. Okay, so thank you so much. We'll see you next time. Bye bye.